Hello everyone, I am Subhi Avasthi, Assistant Professor, PG Department of Computer Science, Arya College, Ludhiana. Today I am going to provide an overview on data structure. First of all, what is data structure? Data structure is a representation of the logical relationship existing between the individual elements of the data. In other words, we can say that a data structure is a way of organizing all the data items that considers not only the elements stored but also their relationship to each other, whether using the list, stacks, graphs, or queues. Data structure affect the design of both the structural and the functional aspect of a program. A program may consist from algorithm plus data structure. You know that an algorithm is a step-by-step process to solve a particular function. This means algorithm is a set of instructions written to carry out the certain task or a particular task, and data structure is a way of organizing the data with their logical relationship that we need to perform for the certain task. To develop a program of an algorithm, we should select an appropriate data structure for that algorithm. Therefore, algorithm and its associated data structure form a program. Data structures are normally divided into the two broad categories, that is primitive data structures and non-primitive data structures. The primitive data structures contains the built-in data types, for example, integer, float, characters, and pointers that you read out in C, C++, Java. And non-primitive data structure contains linked list, linear list, and non-linear list. The linear list contains array, linked list, stack, and queue, and non-linear list contains graphs and trees. The primitive data structures, there are basic structures and directly operated upon by the machine instruction. In general, we can say that different representation on different computers. Integer, floating point numbers, that is decimal numbers, character, constant, string constant, pointer, etc. falls in these categories. Whether in non-primitive data structures, they are more sophisticated with data. These are divided from the primitive data structures. The non-primitive data structure emphasizes on structure of a grouping of homogeneous or same type of, or whether it is a heterogeneous, that is different types of data elements. Basically, non-primitive data structure uses the real world data to store or to manipulate the information. For in non-primitive data structure, we used list, stack, queue, tree, graph are the example of a non-primitive data structure. The design of an efficient data structure must take operation to be performed on the data structure. The non-primitive data structure mainly used following operations, that are create, selection, updating, searching, sorting, merging, and deleting. Difference between them. A primitive data structure is generally a basic structure that is usually built into the languages such as integer or float, whether in a non-primitive data structure is built out of a primitive data structure. For example, to create an array, we need to use the primitive data types, whether to create in a different way, such as a linked list, binary search tree, AVL trees, graph, etc. Data structure describes various types of data structures, that is array. An array is defined as a set of finite numbers of homogeneous, that is same data items. It means an array can contain one type of a data only, either all integers or all float point numbers or all characters. You can use any types of primitive data type while generating an array. Simple syntax of a or example of creating an array is: int is a primitive data type, array RR is a name of an array, 10 is the size of an array, where int specifies the data type and AR specifies the name of array that user can change according to their preference, and the size is defines the how many elements you want to store in the array. User can also change the size depending upon their requirement. Following are the sum of the concept to remember about the array. The individual element of an array can be accessed by specifying the name of the array, that is followed by the index brackets or the square brackets. The first element of array has an index that is 0 value, but it depends upon a user whether he wants to store the elements from 1 to 6 position. But in memory, the array list will start from 0. For example, if your list contains 10 elements, in memory it will be from 0 to 9. The 10th element contains the 9th location because the counting will start from the 0. The element of array will always be stored in a consecutive, means one after the another memory location. They are always contiguous. The number of elements that can be stored in an array, that is the size of array or its length, is given by the following equation. For example, upper bound minus lower bound plus 1. In this formula, you can calculate the size of the array or the length of the array. From the above array, it would be 9 minus 1, 0 plus 1 is equal to 10, where 0 is the lower bound and 9 is the upper bound of the array. Plus 1 to calculate the size of an array. Array can always be read or write through the loop. Without loop, you cannot access the data of the array. If you read a one-dimensional array, it requires one loop, and if you used two-dimensional array, it requires two loops, one in inner surface and one in outer surface. For example, reading an array, for loops start from I is equal to 0, I less than equal to 9 and I plus plus. It starts scanning and you can insert one by one element into this. And you just want to print the array. So in this way, you can use scan in the place of scanf. You can write printf %d, and the and % symbol is not used because in this you are going to write the array element on the screen. If we are reading or writing two-dimensional array, it would require two loops, and similarly the array of n dimension would require n loop. Some common operation performed on array are creation of an array, traversing of an array, insertion of a new element, deletion of a required element, modification of an element, merging of an element. To perform all these operations, you just create an array, whether of any primitive data types. Again, next is the list. List is a linear linked list that can be defined as a collection of various numbers of data item. It is also part of a data structure. Lists are the most commonly used non-primitive data structure. An element of a list must contain at least two fields, one for the information part and other for storing the address of the next element. If your list doesn't contain the next element address or doesn't have the next element, then you can write the cross or null symbol into the link part. As you know, for storing the address, we have a special data structure of a list. The address must be of a pointer type. Consider an example. In this, we have a linked list, that is AAA, BBB, CCC. Had contained the first element pointer from where the linked list will be started. AAA is the information field and the block is contained the address of the second, that is the BB node. And BB node contains the pointer of the CC node. The CC node doesn't have any pointer because after CC node there is no need in the linked list, as you see in the example. Types of linked list that are provided in the DS, that is singly linked list, doubly linked list, single circular linked list, doubly circular linked list. Other classification of data structure is stack. A stack is also an ordered collection of element like array, but it has a special feature that deletion and insertion of the element can be performed only from the one end, that is from the top. Due to this property, it is also called last in first out types of data structure. It could be true of just like a stack of plates placed on table in a party. A guest always take off a fresh plate from the top and the new plates are placed on the stack at the top. It is a non-primitive data structure. When an element is inserted into the stack or removed from the stack, its base remains fixed. where the top of stack changes frequently. In stack we can perform two kind of operation. First is the push operation and second is the pop operation. Push operation is to perform to insert the element into the stack, and deletion of element from the stack is called the pop. So consider the example that are shown in the diagram. The stack is a one and loop. In this, push and pop means insertion and deletion can be performed only from the one end, that is from the top. The stack can be implemented in two ways. First, in using array, by using the static implementation as you create the array, and second is using the pointer, that is using a dynamic implementation, because in this the value, elements and the address is frequently changed. Another classification of data structure is queue. Queue are the first type of data structures, that means FIFO. In a queue, new elements are added to the queue from one end, that is called the rear, and the elements are removed from the other end, that is known as a front. The people standing in a railway reservation row are an example of a queue. Each new person comes and stands at the end of the row, and the person getting their reservation confirmed get out from the row from the front end. The below shows the figure. 10, 20, 30, 40, 50 is a list. The front contains the 10th element and the rear contains the 5th position. If we want to delete the element, it will be deleted from the front, that is the 10th, and if you want to insert an element, it will be inserted after the 50. Another classification of data structure is tree. A tree can be defined as a finite set of data items. The data items of trees are known as nodes. There is a non-linear data types of data structure in which data items are arranged or sorted or stored in a sequence. Tree represent the hierarchical relationship between the various elements. There is a special data item at the top of hierarchy that is known as the root of the tree. The remaining data items are partitioned into the number of mutual exclusive subset, each of which is itself a tree, which is called the subtree. The tree always grows in a length towards bottom in the end, unlike the natural trees which grows upward. The tree structure organizes the data into the branches which related to the information. For example, A is the root, B, C is known as the child of the A node, and D, E is known as the child of a B node, F, G is known as the child of the C node, D, E, F, G doesn't contain any child, so they are known as a leaf node. Another classification of data structure is graph. Graph is a mathematical non-linear data structure capable of representing many kinds of physical structures. It founds the application in geography, chemistry and engineering science. Defining a graph, we use G, V, E. In this, V is a vertices and E is a edges. And edges connect a pair of vertices, and many have weight such as length, cost and another measuring instrument for according to the graph. Vertices on the graph are shown as the point of the circle, and edges are drawn as an arc or a line segment. Consider the example. V1, V2, V3, V5, V4 are the vertices of the graph. V1, V2 are connected by one edge, that is directed, means we can go from V1 to V2 but cannot come from V to V1 because it is a directed graph. The weightage from going from V1 to V2 is 10 and from V2 to V5 is 6. In indirected graph, the line doesn't contain any kind of arrow. It means it is a two-way relationship, means we can go from V1 to V2. As usual, we can come from V2 to V1. Types of graphs are directed graphs, undirected graphs. Directed graphs contains the arrow symbols. Undirected graph only contains simple lines. Simple graph in this doesn't have any kind of a weightage. Weighted graph contains the weightage, means goes from going from one node to the another node. Connected graph when your all nodes are connected with each other. Non-connected graph whether a single node is doesn't contain connected with another node. Thank you so much. I hope this video lecture on data structure classification is useful for you.